This is Lesson 64, Algebra 2, Arithmetic Series. Pages 148, 149. A series is taking a sequence with a pattern, and we're going to look at geometric sequences in the next lessons to come. But when you do the series, you're simply adding them together, and one of the other lessons that we'll do soon is a different notation called sigma notation used with series. But a series is a sum of terms. So in this case, we're looking at arithmetic sequences. Well, if you remember, arithmetic sequences where you're given some terms and you notice that you're adding something every time. That number may be a positive number, that number may be a negative number. You can do them with fractions and decimals. We tend to, especially in Algebra 2, if this is the first time you've seen them, stick with the integers. The formula, and it's a pretty easy formula to prove, is S sub n. I'm going to go ahead and give you the formula, and the variables pretty much stand for what we've used already. So if we go back and look at our individual term, and we do need that. So if we're going to do a term in arithmetic sequence, remember it was A sub n is equal to A sub 1 plus n minus 1 times d. A sub n was any term in the sequence. If you want to flip back, this is on page 144. It's any term in the sequence other than the first one. N is the number of that term. So if it's the 50th term or the 5th term. A sub 1 is the first term. N is the number of this term. So if you're using the 50th term, that term might be 128 or something. So the number of the term, and then the d. D is what you're adding every time. It may be a negative number. Well, up here, same thing. How many terms are you adding? Because this n is that n, because how many terms are we adding up? Sum, S stands for the sum, and the A sub 1, remember, is the first term. And now A sub n will be the last term. Okay, so we're going to start off with a pretty easy one. We're given a sequence that A sub 1 is 6, because sometimes they give you the sequence, but a lot of times in this they just set up the data and then you can set the sequence up. So we got A sub 1 is equal to 6. We're going to let A sub n be 118, and we're going to let n be 15. Now what does that mean? Okay, I've got my blanks. Now, I'm not going to put 15 blanks, but that's how many terms I have. And because we're doing addition, I'm going to go ahead and put pluses between them. And then I'm going to go out here and just put dot, 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 and put so this is the first one, second one, third one, fourth one, and then this would be the 15th one. You have to know the beginning and the end of your sequence. And you have to know how many blanks you have, which in this case is 15. Do you have to list them all? No. But as long as you have these three things, the number of terms you're going to add in the first and last, you can add them. Well, we know the first one, and we are going all the way to our 15th term, which is 118. So notice in this case, we don't have what the d is. But if you look back in your equation, you don't have to know the d. Now, we could take this information and find d if we needed it, but we don't even need d here. All we need is how many terms are we adding? 15 blanks. What's the first one? And what's the last one? And the last one it says A sub n is 118. Another way to have said that is they could have said A sub 15 is equal to 118. That's putting this information together as one statement. So don't let that bother you. It's the number of terms. So S sub, how many are we adding? We're adding 15 terms. Is 15 divided by 2. Now, even though that's a decimal, and you look at this, we're adding integers here. You know, we're going from 6 to 18, and whatever the D is, it's, you know, they're all integers. So, but it'll take care of itself. It's kind of interesting the way the arithmetic works. And the first term is 6, and the last term is 118. Now, if you punch that in your calculator, I've already got it done. Just be careful with your parentheses. You put 7.5 and go ahead and add those to 124, but the whole sum is 930. Now, you could have, well, you can write them out and add them up if you know them, but see, in this case, you didn't even know all these terms in between. You could have done some arithmetic, gone back to this formula, and found the D, find the terms, but that eats up a lot of your time. So in this case, it's just plug in first term, last term, and the number of term. Okay, let's do a second problem. Let's let a sub 1 be 9. Actually, it's negative 9. And we're going to let a sub n be 48, negative 48. And we're going to add up 14 terms. So now remember, this simply says that, you put this together as one statement, it says the 14th term is negative 48. So we want to find the sum of these terms. Let's just draw it. Again, some of us, including me, need a visual. Yeah, I don't like the way I wrote that. Let me put that under here. So we've got the first term, second term, third term, all the way up to the 14th term. So we're going to be adding 14 numbers. The first one is negative 9. The last one is negative 48, and that is the 14th term. And we want to add these numbers up, which seems kind of weird that you can add up numbers and you don't even know what they are. But it's a pattern. Because it says it's an arithmetic series, then we know it has a pattern to it, and then we're adding a number every time, the same number every time. So S sum of 14 terms is equal to, how many terms are we adding? 14 over 2 times the first term plus the last term, which in this case is the 14th term. So we type that on our calculator, and I don't have that one worked out, so I'll do that one. I'm going to go ahead and just type 7 times, I'm not on the camera. I'm in my parentheses, I'm going to put negative 9 plus negative 48, and I got negative 399. Okay. And those pretty much are the simplest because you're given the information that you need to be able to find the problem. You're just given. They give you the first term, they give you the last term, and how many you're adding. Now, let's look at a little bit different type. Let's do one where you're given the first term. So we're going to use a sub 1 is equal to 33. This time we're given D is 8, and we're going to add up, let's add up 20 of them. Because if I make that a small number, it's probably just as easy to, let me scoop that. Let's see, I might have to move the iPad. See if I can get it straight. There we go. Now, in this case, let's just see what we have. So we've got a sequence. I've got a sub 1, a sub 2, a sub 3, a sub 4, and then I'm going to put plus dot, 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 a sub 20. You know, if it's just said add up the first 4 terms, then it would probably be easier just to find them, add them up. So I made the number, got that off the camera. I made the number here a little bit bigger because I wanted it to be a little more than what you would just normally add up. Even with a calculator, it's a little time consuming. Now, what do we know? Now, what do we need to know? If we look back up at our formula, we have to know how many terms we're adding. We know that's 20. We need to know the first term, which is 33, but we need to know the 20th term, which we don't. So I've got a sub 1 is 33, but I have to know this one right here. Now, I don't want to go 33 plus 8 plus 8 plus 8 20 times. That's just, even on the calculator, you can do it kind of fast, but it's still time consuming. So let's go back to our formula. I don't know if it's on the camera. Let me slide up right here. Remember, if you need to find a term in the arithmetic sequence, then you can use the formula from the sequence section. So you've got a sub n. Let's see, where do we want to do that? How about up here? A sub n Let me section that off. A sub n is equal to a sub 1 plus n minus 1 times d. Now, I need to know the 20th term. So a sub 20, see, because I'm trying to get that right here. That's what I want to put in this blank. So a sub 20 equals the first term we know, plus 20 minus 1, and we've done those, so hopefully it's okay with you if I go ahead and put 19 there, times my d, which is 8. I'm adding 8 every time. And I can actually find those. That's pretty easy. 33 plus 8 equals 41. And then 49. And so you're just adding 8. But again, adding up 8 20 times is kind of time consuming. But look at this. We can do all that arithmetic in one step. So I've got 33 plus 19 times 8. And I've got 185. Now, why does that help me? Because now I know S sub n, so I'm adding 20 terms. I'm at the bottom of the page, and it's just about to not want to balance here. Let's see if that's going to work. S sub 20 is equal to 20 over 2. How many terms am I adding? And then the first term, which we know is 33. Now, a lot of people want to put 20 there, but see, the 20th term, 120. That would only been if it had been 1, 2, 3, 4. But we want the 20th term, which was 185. It's going to be a pretty big number. I mean, you would know that just by looking. Just 33 plus 41 plus 49 is a big number. So I'm going to go ahead and do, and of course, I'm never on the camera. Let's do it like this. I'm going to go ahead and do 10 times, and I've got 33 plus 185, and I got 2,180, and that's my sum. Okay, I'm going to stop, situate the paper, and start on page 149.